4.8 Application and Models. What we should learn: how to solve real-life problems involving right triangles, how to solve real-life problems involving directional bearing, and how to solve real-life problems by harmonic motion. The first part here, we're going to solve a right triangle. They want to find all unknown sizes and angles. Well, first, if we want to find angle B, we don't have that one. That's just going to be 180 minus 90 minus 34.2. Take that real quick on the calculator, because I don't want to subtract those decimals by hand. So 180 minus 90, which is just 90, minus 34.2, 55.8 is angle B. Okay, we have the angles now. We have A, we have B, and we have C. We got to find A and C. Well, I'm just going to use Soh Cah Toa. That's my key to most things. Soh Cah Toa. We have this angle. This is opposite. This is adjacent. This is hypotenuse. We have adjacent. So I could use Toa to figure out the opposite, or I could use cosine to figure out the hypotenuse. It really doesn't matter. I'm going to use Toa. We'll do tan of 34.2 equals A over 19.4. Then we're going to cross multiply to get A equals 19.4 times tan of 34.2. So again, we put that into the calculator. 19.4 times tan of 34.2. We get, I must be in radians, and I should change that to degrees, because we're doing, mainly because they showed us degrees. We're doing triangle in degrees. If you look at the problem is in degrees, so it should be in the right form. We'll go back up here and click it again, hit enter, and I get 13.2. A is 13.2. All we need now is the hypotenuse C. Well, in this case, I could just do the Pythagorean theorem. If you want, you could do cosine to figure out C. I'm just going to do Pythagorean theorem. 19.4 squared plus 13.2 squared equals C squared. Square root both sides. And C is an equal. I did it on the calculator off camera just to save you guys some time watching me type numbers into our calculator. I'm going to get about 23.46. Make sure it works. C should be the biggest. It is bigger than these two. It does make sense. That's how you do the first one. Next one, little application problem. The safety regulation that states that the maximum angle elevation for a rescue ladder should be 72 degrees. So there's my rescue ladder, 72 degrees. Fire department's longest ladder is 110. So there's 110. What is the maximum safety rescue height? I just want to find out what this is, the height is. Well, if you look at it, we just have a right triangle. We have this. This is 72. This is 110, and this is A. That seems like a Soh Cah Toa problem again. Soh Cah Toa. We have opposite and hypotenuse. That is O and H. That is sine. We're going to do sine of 72 equals A over 110. Then we can just cross multiply. A equals 110 sine of 72. We'll put that into the calculator also, and we get approximately 104.62. That's the height in feet of the safety ladder could get to. Find the side of a right triangle. At the point 200 feet away from the base of the building, so there's my 200 feet. The angle elevation of the bottom of the smokestack is 35 feet. See this one right here is 35, and this one's 53. Find the height S. We want to find this height. In this case, I would just find the height of the bigger one minus the height of the smaller one. We have like basically two triangles here. We have, this is 53, this is 200, and then we have, this is 35, this is 200. So this one is a smaller triangle here. That gives us A. And all of this is S plus A. S is just like this part right here. And A is like the rest of it. So I'm just going to make all this like X. And the way to find S is just figure out what X is and minus A. And these look like another Soh Cah Toa problem. This is opposite and adjacent. Same thing here. Opposite and adjacent. We're just going to set up two tan equations, then we'll subtract them. Tan of 53 equals X over 200. Over here we have tan of 35 equals A over 200. And to find S, we're just going to get those answers, subtract them. Let's cross multiply real quick. I get X equals 200 times tan of 53. And over here, cross multiply, you get A equals 200 times tan of 35. So if we subtract those two, S is an equal 200 tan of 53 minus 200 tan of 35. And put that into your calculator, and we're going to get approximately 125.37 feet. And I'm skipping the calculator work so that you guys could do that. So that's the idea though. You set up the two separate triangles, the bigger one, the smaller one, and to find S, which is this part here, you just do the bigger triangle minus the smaller triangle. You should get about 125 feet. The next one, they want to find the angle of depression. A swimming pool is 20 meters long and 12 meters. The bottom of the pool is such that the water depth is 1.3 meters, like right there. And the shallow end is 4 meters at the deep end. Like 1.3, but the whole thing is like 4 meters high. Find the angle of depression at the bottom. Really all we care about is this triangle right here. And that triangle is 2.7 That's the x we're looking for. This is 20 meters. So the way we're going to solve this, we haven't done this with the calculator yet, is we're going to use Soh Cah Toa, but in reverse. Well, not in reverse, but we're going to use inverse functions. So what do we have here? We have opposite, and we have adjacent. So this should be tan Toa, and instead of tan of x equals opposite 2.7 over 20, like that. And then get rid of the tan, we're going to do inverse tan, or arctan. Same thing, tan negative 1, tan negative 1, x equals, put this into our calculator, second tan of 2.7. I want to show you this one over 20. I'm still in degrees, so you get a nice degree answer of 7.69 degrees. That's the angle of depression for this triangle, for this swimming pool. Keep in mind that's in degrees. You can also answer in radian because they didn't really specify which one they wanted to. Okay, let's talk about bearing. The thing about bearing, unlike our angle measurement, we started at 0 here, and then we went up or down. Bearing starts either north or south, depending on what they tell you. You start north or south. By default, it's north, but they could tell you south really easily, like here. So it says south, so we're starting the south end, and then we're going to go 35 meters east. You go from south, you go 35. There's your angle. This one says north, 80 west. So you start north, and you go from the north, you're going to go 80 west. That's where that comes from. The last one here, north, 45 degrees east. You start north, and you go 45 degrees east. That's how bearing works. Bearing starts at the north or the south, and then from there you go east or west. Let's find directions in terms of the Shipley's port at noon has due west. That's right here. There's your port, and we're going due west at 20 knots or 20 nautical miles. At 2 p.m., it's been 2 hours because it's left at noon. The ship changes course and goes north 54 degrees west. Notice how it says 40 nautical miles because it went for 2 hours this way. And then from here, they change the bearing to go north 54 degrees west because you always go from north or south. We're going north 54 degrees west. And it goes that for another hour, looks like. Find the ship's bearing the distance from the departure at 3 p.m. We're trying to find two things, the bearing and the distance departure. Distance departure is just this thing right here. We got to figure out like that line right there. How much is that line? The bearing is basically, so from here, and pretend this is like the northwest little grid there. The bearing, we're going to go, got to figure out what that angle is. That's going to be the bearing. To do that, we got to figure out what this angle is right here, because then we can just subtract it from 90. That's the idea. That's like the goal here. What we really need to do is look at this like triangle. It's a big old triangle like this. Go down, up. It's a giant right triangle. We want to find the hypotenuse for this giant right triangle, and we don't find this angle for the giant right triangle. But first, let's figure out what this triangle, all these parts of this triangle are. This is 54 degrees. It is a 90-degree angle there. If I want to figure out what this is, it's going to be 90 minus 54, which is going to be 36. That's 36. And that's all I need to figure out what these two sides are. And if I can figure out what these two sides are, I can figure out the hypotenuse by doing a squared, b squared, c squared. Let's find that. Let's figure out what this side is. Well, because remember, we have a little right triangle right there, where I know this is 20, this is 36. To save you some time, we're just going to do, I want to figure out what b and d are, and that's just going to be Soh Cah Toa. I'll set them up, but I'll just mostly, if I want to figure out what d is, this is cosine. Cosine of 36 equals d over 20. And then to figure out what b is, I'm going to do sine of 36 equals b over 20. I get d equals 16.2. I'm going to round it, 16.2. And then b equals 11.8 if I round it. Right. Now, if I want to figure out what the hypotenuse is, I can just do a giant right triangle. We have a giant right triangle here, where this side is 11.8. This whole bottom is 56.2. I'm adding the 16 with the 40 to get 56.2. And I'm going to figure out what the hypotenuse is. So I'm just going to do a squared plus b squared equals c squared. And that's going to give us this whole hypotenuse. Square root both sides, and c, you put in my calculator, not to deal with me plugging it in, but the point an approximation. So that's the number of nautical miles, about 57.4 nautical miles they have traveled. Now, we got to figure out what this angle is, because if we can figure out what that angle is, then I just subtract it from when I subtracted 90, we could get the bearing. Well, I can just do arctan, right? If I want to figure out what this angle is, I'm going to do arctan of 11.8 over 56.2. We're going to take arctan of both sides, and we get about 11.82. That's how much this little guy is. 11.82. But remember, the way nautical miles, if I want to give a bearing, you don't go from the horizon up, you go from north or south up. What we want to find out is what this guy is. So we're just going to do 90 minus 11.82, and we're going to get approximately 78.18. And then that's going to be at a heading of, we're starting north and we're going west. See here, we started north, we go west. We're going to go north, 78.2 west. That's our bearing, and these are the nautical miles we traveled. That's how bearing works. Okay, one last type of problem. Harmonic motion. Harmonic motion is just a sine cosine motion. It's something that oscillates or rotates. In this ball example, you can see it starts off at, you can see there's a center of 0, and then it goes up to 10, and it goes back down to 10. That's the amplitude. So it's going to keep on oscillating from 10 to stretch down to stretch back up. It's going to keep on going like this. That's harmonic motion. You can see here, a simple harmonic motion. The distance from the origin, the distance is given by this, a sine theta, where sine, well, w, I forget which one that is. In our period, that's just like our b, 2 pi over b. Frequency, the period is, we're just going to use our normal a sine bx. You can think about it that way. I guess time, because we're doing the application problem. Period is still going to be 2 pi over b. Frequency is b over 2 pi. You just flip it. That's the frequency. I mean, how often does it do it? You just flip the rotate, you just flip the period. And that's it. Other than that, it's the same thing. Look at the example here. Writing an example of a simple harmonic motion of the ball illustrating that thing, where the period's 4 seconds. We need that. Period's 4 seconds. Let's go check if it's a sine or cosine graph. Now, look right here. It starts at 0. The graph starts at 0. Then it's going to go, like, looks like down and up. That is, before it goes back to equilibrium, that's a sine graph because it starts in the middle. We're going to do a sine graph here. We're going to use the sine formula, which is, well, I'll write their formula. D equals A sine bt. All I got to find is a and bt. What is a? Look up here. 10. It goes from 0 to 10 to negative 10. Boom. Only thing we left is only thing we left is b. But remember, b has to do with the period. Period equals 2 pi over b. The total of the period is 4 seconds. 4 equals 2 pi over b over 1. Cross multiply. I'm going to get 4b equals 2 pi. Divide by 4. And you get b equals pi over 2. And there's our equation. D equals 10 sine of pi over 2. And they want to know what the frequency of the motion. We just use a formula for frequency, which is b over 2 pi. So that's going to be, our b is pi over 2 over, divided by 2 pi, pi over 2 times the reciprocal, 1 over 2 pi. Pi's cancel, and you get 1 over 4 cycles per second. Okay, last one. They're going to give us a simple harmonic motion. They want us to answer a couple of questions. So first, what's the maximum displacement? Well, that's just the amplitude. Remember, if you're doing a cosine graph or a sine graph, maximum displacement is just the amp from here to here. So maximum displacement of this one is our amplitude, 6. B, what's the frequency? That's just the formula, b over 2 pi. The formula is the reciprocal of the period formula. Our b here is sitting next to your t. So this is our b. So 3 pi over 4 over 2 pi. And again, don't freak out when you see that. That's just a divide sign. So 3 pi over 4 divided by 2 pi, 3 pi over 4 times the reciprocal. Pi's will cancel, and you get 3 over 8 cycles per second. So that's our frequency. What's the value of t? What's the value of d when t equals 4? That's just plugging it in. D equals 6 cosine of 3 pi over 4 times 4. Well, these cancel out, and we get 6 cosine of 3t, 3 pi. We should not do that by now. But here's 0, here's pi, here's 2 pi, 3 pi will be over here. You're on a unit circle. Remember, you don't draw a triangle when you're on a unit circle. It's just the point. 1, negative 0, negative 1, 0. Cosine is the x value, negative 1. All this is negative 1. Times it by 6, you get negative 6. And then d, find the least positive value when d equals 0. It's kind of opposite. It's like backwards. For d, they want to plug in 0. 0 equals 6 cosine 3 pi over 4t. Now, we actually haven't learned how to solve that yet. That's a skill we're going to learn in the future, is how to solve trig function. For now, we'll let the calculator handle it. We're just going to graph it, and we're going to find the first time it equals 0. Like, let's bring my calculator so you can see it. It's in radian mode, like I have it. We'll go y equals, clear this, and then we're going to go 6 cosine 3 pi over 4 x. Let's go window. Let's go zoom. We'll put zoom standard for now. No, I have it in radians. No, I have it in degrees. It has to be in radians when you graph trig. Okay, like this. And we want to find the first time it's 0. We want to find that point right there. And the way you find that on your calculator to find the 0 is you put second calculate, trace, and you find the 0 button. Now the way it works is you're going to go, I want that point. It's going to say, like right now, it says a left bound. You want to put something where you know that's the left bound of it. So for us, this is the thing we want, right there-ish. We can go a little left, so that makes our left bound. And what's our right bound? We go a little past it, it's our right bound. Now the calculator knows to search between those two values. So you put guess, you put yes, and it finds it for you. 0.667 or 2/3. And that's the answer, and that's the lesson.